Welcome to this explainer. If you've been paying any attention to artificial intelligence lately, you've definitely noticed that the conversation has shifted. We're not just talking about simple chatbots anymore, we're talking about completely autonomous systems and massively complex workflows. So today, we are doing a deep teardown of the top AI agent architectures. And honestly, understanding these blueprints is exactly how you take an AI's capabilities and multiply them 10x. So it's the million-dollar question, isn't it? How do large language models actually move from just generating clever text in a chat window to executing real tasks in the real world? How are they booking flights, scraping websites, analyzing giant spreadsheets, or literally writing and testing their own code? You see, a raw language model is essentially a brain in a jar. It has these unbelievable reasoning capabilities, sure, but it has no hands to interact with the world and absolutely no long-term memory to keep track of massive projects. So to unlock that 10x improvement in utility, we've got to give that brain a nervous system. And that nervous system is exactly what we call an agent framework. Before we dive into the dense visuals, let's just lock in this definition real quick. An agent framework is a structured system that connects large language models to external tools, data storage, and processing loops, which allows them to autonomously execute complex tasks. Think of the LLM as your engine. The framework, well, that's your chassis, the wheels, the steering wheel, and the GPS. It's the essential infrastructure that takes a simple prompt and turns it into an automated, multi-step action. To get us there, here is our agenda for today. First, we'll meet the AI agents. Second, we'll look at data-driven frameworks. Third, multi-agent collaboration. Fourth, we'll enter semantic kernel. And finally, number 5, we'll pull back for the big picture. All right, let's jump right into part 1, meet the AI agents. Here is a map of the ecosystem. So here it is, the top AI agent frameworks you absolutely need to know. No, I know what you might be thinking right off the bat. This looks like a highly complicated subway map, right? You've got different lanes, tons of icons, arrows pointing everywhere, starting with LangChain at the very top and going all the way down to semantic kernel at the bottom. I fully acknowledge this is a dense visual, but seriously, don't worry. This diagram is the absolute key to understanding how that 10x improvement in AI workflows is actually achieved. And I promise you, we are going to systematically break it down row by row until you totally understand every single path. Which brings us to section 2, data-driven frameworks, specifically LangChain and LlamaIndex. Okay, look specifically at row 01 for LangChain and row 04 down there for LlamaIndex. Direct your attention all the way to the far right. Notice those blue stacked cylinder icons? Those are your vector stores. Both of these frameworks place a massive shared emphasis on dealing with documents and vector stores. You can basically think of a vector store as long-term memory for an AI. If you want your AI to ingest 10,000 pages of legal documents and then instantly recall the exact right clause, you absolutely need these data-driven pathways. Let's look a little closer at LlamaIndexed on row 04 to see exactly how this plays out. Check out the distinct, linear flow moving from left to right. It starts with raw data, which is represented by those document and database icons. Step 1 is load, shown by that purple spinner. Step 2 is parse, where the data actually gets broken down. You can see the book and magnifying glass there. Step 3 is index, which structures that data. And finally, step 4 pushes it right into those blue vector stores. So the really crucial point here is how this framework takes raw, totally unstructured data and completely transforms it into a highly searchable format. When a user makes a query at the bottom, LlamaIndex grabs the prompt, combines it with perfectly retrieved data from the vector store, and feeds that massive context package directly to the LLM to get a brilliant, highly informed response. It's just a super clean, incredibly powerful data pipeline. Now let's glance back up to row 01 for a second to look at LangChain. LangChain takes a slightly different approach to connecting these components. While it definitely still uses document loaders and vector stores, it utilizes its signature chains, which are represented by those overlapping blue and gold link icons. LangChain essentially links user prompts to agents, which then reach out to external tools or document loaders, pull the data, and loop it right back through the LLM. It's a highly modular way of just snapping together different pieces of the AI puzzle to create a continuous processing loop. Let's move on to section 3. Multi-agent collaboration. We'll be looking at AutoGen and Crew AI. Shift your focus right to the middle of our map here, rows 02 and 03. You see those multiple little robot head icons clustered together? This represents collaborative agents. And guys, this is the secret sauce to that 10x improvement. Instead of forcing one single AI to juggle researching and writing and fact-checking all at once, which almost always leads to mediocre results or hallucinations, you spin up specialized agents that work in parallel. They debate and they refine their work simultaneously. This perfectly illustrates the different philosophies between these two multi-agent juggernauts. Look at AutoGen on row O2. Its core dynamic is conversation patterns. The agents literally chat back and forth with each other to solve a problem. Even cooler, look at the key actors. You see a little construction worker icon labeled Human in Loop right alongside a code executor terminal. AutoGen is amazing at writing code, testing it, and then actually asking a human for permission before proceeding. Now compare that to Crew AI on row O3. Instead of a free-flowing chat, its core dynamic is a strict process leading to defined tasks. You literally see a robot labeled writer passing work directly to an editor. It mimics a real-world corporate structure to get things done with incredible, rigid precision. No water cooler chat required, right? Moving into Section 4, enter semantic kernel and enterprise integration. Let's drop down to row 05 and see how this builds on everything we've just learned. Notice that the icons here are very different from the rest of the board. You've got traditional programming language logos, like the blue C for C# and the coffee cup for Java. You see folders labeled classes and documents for templates and API specs. Semantic Kernel is actually built by Microsoft, and it's specifically designed for enterprise developers who want to integrate AI into massive existing codebases. It quite literally speaks the language of traditional software engineering. And the real magic of Semantic Kernel sits right there in the middle of row 05. The kernel plugins, which you can see represented by that massive electrical plug. It essentially funnels your traditional programming elements right through these plugins to seamlessly reach the AI service. It standardizes exactly how AI interacts with your existing company's software, making that massive 10x capability multiplier safe, predictable, and fully enterprise-ready. All right, Section 5, the big picture. Let's look at the foundational building blocks of AI. So despite their very different approaches, whether we're talking about Llama Index's slick data pipelines, Crew AI's rigid corporate personas, or Semantic Kernel's enterprise plugins, they all share the exact same foundational building blocks. Every single framework here has large language models at the core, represented by those glowing Spark icons on the right side of the diagram. They all utilize vector stores to give the AI long-term memory. They all feature wrench and gear icons, meaning they connect to external tools and APIs so the AI can actually take action out in the real world. And finally, they all start with prompts and user queries on the left as the initial trigger. These are literally the universal ingredients for autonomous AI. Let's just take a moment to appreciate this complete architectural map again. What started out looking like a totally dense wall of icons is now a really clear set of strategic choices. Need deep data retrieval? Look to the top. Need specialized AI workers collaborating on a project? Look to the center. Integrating into a massive traditional codebase? Look to the bottom. Truly understanding this map is exactly how businesses engineer systems that actually deliver that 10x productivity multiplier we've been talking about. They aren't just chatting anymore. They are building robust, autonomous infrastructure. And that brings us to a really critical realization. We are no longer limited by the intelligence of one single AI model. We are now only limited by how creatively we can string them together with tools, memory, and each other. I mean, think about it. If a single agent connected to a database can revolutionize a workflow today, what happens tomorrow when your entire organization is being run by a multi-agent ecosystem that collaborates at the speed of light? The blueprints for that reality are right here on this map. So the only question left is, what are you going to build with them? Thank you so much for joining me in this explainer. Keep exploring, and I'll catch you next time.